Every single molecule and every single compound has a very precise name. And we have a system that we use in order to name these compounds. It's generally called nomenclature, but nomenclature is really just a fancy way of saying a system of naming. Okay, so for example, we as humans, we have a system of naming ourselves. We have a first name, which is the individual. Then we have a last name, which is of the family. Some of us have a middle name and some of us have some other last names, but it's a very precise system of naming depending on the culture in which you come from. So that is our nomenclature as humans, and we have a nomenclature for covalent compounds, and we have a separate nomenclature for ionic compounds. We don't have one for metals though. So the representative particle, basically what we call these are molecules. So anytime you ever hear the word molecule, we're talking specifically about covalence. We're not talking about ionics. Those are sometimes called salts. Those are sometimes just called ionic compounds. But molecules are specifically your covalents. Remember, these are nonmetals and nonmetals. So just as a quick review, remember there's this little staircase right here. Their nonmetals are all here and hydrogen, right? So if it's only those elements, a nonmetal with a nonmetal, then that is going to be a covalent molecule. And again, it's just nonmetal and nonmetal, okay? Now, what we use is a prefix in order to indicate the number of atoms of each element is in this particular molecule, okay? So I'm going to go ahead and jump right down here first for a reason. The prefixes are pretty simple. You may have heard of these. These are all Greek. So for example, mono means one, di means two, tri is three, tetra is four, penta is five, hexa is six, hepta is seven, octa is eight, nona is nine, and deca is 10. Most of those are very easy to memorize. Hepta being seven, we probably don't hear that very often. So that one you might just kind of need to focus on. The one that people always seem to forget is tetra. An easy way to remember tetra is if you think about the game of Tetris, every single piece is 4 squares, right? Every single piece in Tetris is 4 squares because that's where Tetris got its name from. Okay, so tetra is 4. Now, we would add these prefixes, and we're going to do some practice here in just a moment, to indicate the number of atoms in each of each element in a molecule. But before we do, I do want to show you guys some exceptions to this rule. There are some common molecules here, and you guys just need to know these. Now, these are when they are by themselves, okay? I'll explain what that means, but I'm going to start with number 2. Cl2, we do not call that dichloride. We just call that chlorine. Chlorine is a gas, and when it's in the gaseous state, it's going to be Cl2. It's never Cl by itself. It's going to be Cl2. They're going to share their electrons. 2 atoms of chlorine are going to share their electrons equally in a nonpolar bond, and we just call that chlorine, okay? F2, this is going to be fluorine. Again, notice the spelling of fluorine, Fluo. Br2 is bromine, okay? Again, these are not dibromide, this is not difluoride, this is not dichloride. These are just chlorine, fluorine, and bromine, because this is how they're going to find them in their natural pure state. I2, again, is just regular iodine, not diiodide. Oxygen, again, if it's by itself, if it's in a compound, this is not necessarily true, but if it's the oxygen that's in the air, that makes about 25% of the air, then that's going to be O2. Hydrogen, H2, nitrogen, N2. So these 7, again, you need to memorize these. They're all gases and liquids, and they're the element, we call them divalent. That's the fancy word, divalent. Because again, they are always found in 2s when they're by themselves in the pure form. They always buddy up into 2s, and we don't indicate the suffix or the prefix because you're never going to find oxygen by itself, right? If we have pure oxygen as a gas, they're going to pair up and they're always going to be in pairs, O2, not O3, not O, but O2. Ammonia, you guys also need to know this one, it's NH3. NH3, ammonium is NH4, NH3 is ammonia. We do not call that mononitrogen trihydride. This is just ammonia. So if you ever seen ammonia, it's NH3. Okay, let me clear all this and scroll down. Oops. Okay, let me give you guys an example real quick. I'm going to go ahead and leave these prefixes up here so you guys can see that. Okay, so again, there's going to be a prefix. Could be mono. It could be di. It could be really anything. Okay, these are going to be a prefix. Then you have the name of your element. Oh my gosh, sorry guys. Then you have the name of the element next, and then so that's the first element. And then over here you have the second element, another prefix. And notice the ending is always going to end with "ide." That was not the case with the ones up there, the divalent ones, because again they're a little special. But they're always going to end in "ide." So notice "ide," 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 "ide." Okay, they always end in "ide," but the first compound does not. Right? This is just carbon, sulfur, phosphorus, sulfur, iodine, sulfur. Those suffixes only are on the second compound. Only the second compound. Okay? So let's start with number 9. It says carbon disulfide. Carbon, again, notice it has no prefix. If it has no prefix, we can assume it's going to be 1. If it's 2 carbons, it would be dicarbon. If it was 5 carbons, it'd be pentacarbon. But because it just says carbon, we can assume there's only 1. Okay? Disulfide tells me it's sulfur. And di, again, is 2, so it's CS2. It's a suffix, and it goes after the element. That tells me that there's 2 sulfurs for every 1 carbon, or carbon disulfide. So that's the way that works. Okay, the next one, number 10, we have sulfur trioxide. Again, there is no prefix here, so that means it's just regular sulfur. There is no number here. Okay, there is no number because, again, it's just sulfur. Trioxide. Trioxide, again, tri is 3, so oxide, 3, SO3. Diphosphorus, okay, so now we have a prefix, diphosphorus. You guys know phosphorus, again, is P. Di means there's 2. Trioxide, oxide is oxygen, trioxide. That's diphosphorus trioxide. This is getting pretty easy, right? You guys can figure this out. Trisulfur, so there's sulfur, there's 3 of them. Non-oxide. Okay, so non-oxide, that sounds kind of funny, right? But remember, nana is right here. So oxide is oxygen, and nana means 9. Okay. Number 16, iodine monobromide. Again, no prefix, so it's just regular iodine. Monobromide. Okay, that's interesting. Monobromide. So here they did not say mono, but here they do. You have to say a prefix on the second element, no matter what. There always has to be a prefix. So in this case, it's just IBR1, but we don't write the 1 because that's kind of silly. It's kind of redundant. So it's just IBR. IBR is iodine monobromide. Tetrasulfur dinitride. Sulfur, tetra means 4. Nitride is nitrogen, and there's 2 of them because there's di, and tetra means 4. So tetrasulfur dinitride. I'm going to go ahead and jump up over to here. Carbon tetrachloride. Carbon, again, no mono, so it's assumed to be just a carbon. Tetrachloride, chloride is Cl. Tetra means 4, so there's carbon tetrachloride. Dinitrogen, N2. Pentoxide, notice it's not pentaoxide or pentooxide. We drop off the second O, so it's just pentoxide, not pentaoxide. Pentoxide is O5. Dinitrogen trioxide, dinitrogen, so there's nitrogen, 2 of them. Oxide, trioxide. Okay? Now let's go the other direction. So let's start with back here down at number 18 on the bottom left. So we have P3O8. P3O8. So because there's a 3, I'm going to start with tri. P is phosphorus. triphosphorus, and then we have 8, so that would be oxide. Again, we don't do the 2 O's back to back. We don't do octaoxide. That just sounds funny, right? Octoxide sounds a little bit better. It'll sound more natural as we do this more. It may not sound natural to you yet, but it will. So triphosphorus octoxide. We have C2S6, so that is dicarbon, and then we have hexasulfide. Again, notice they end in ide. Okay, the second one always ends in ide. Number 20, into H4, that would be dinitrogen, tetra, tetrahydride. Remember, hydrogen is a nonmetal. Hydrogen becomes hydride. CO2, oh, this is going to be easy. You guys already know this. It's carbon dioxide. Carbon dioxide, you guys know that. Again, it's not monocarbon dioxide, it's just carbon dioxide. Cl2O7, these are getting funky. Dichlorine, make sure you guys spell these correctly. Dichlorine heptaoxide. Dichlorine heptaoxide. AS4O6, wow. Tetra arsenic. Wow. Hexa oxide, or hexoxide. Yeah, hexoxide. Quick. Hexoxide. Tetraarsenic hexoxide. IF, that is just going to be, again, we don't say monoiodine, we just say iodine. Mono, this one always gets a prefix no matter what, fluoride. Again, ide, right? Again, the first one does not need a prefix unless it needs one. So that's the nomenclature of how to write the formulas and how to write the names of only covalent compounds. These are the easy ones. The ionics are a little bit more tricky. Next, we're going to learn how to draw them and show how to draw a covalent compound. That'll come later. And of course, we're going to go into ionics very soon.